So I know all are about Docker, right? All of you?
Yes.
Yes.
Yes. Then except Amol, the others, anyone can describe what is Docker? Anyone?
It's a container to process the applications.
Okay.
Again, it is a container. It has like a Docker engine, which is a open platform for developing or running application.
Hmm. Okay. Got it. So okay. Shilpa, today we will start the Docker, okay? The topic Docker. And how
Okay,
you?
sure. I'm fine. Getting comfortable.
Okay, fine.
Thank you.
So yeah. So before jumping into Docker, first we need to know why we are using Docker. Okay. So before Docker, how we deploy application? So simple. We install we configure a virtual machine or a physical machine. Okay. VM. We talk these things, right? Physical, virtual or physical machine. And top of the virtual machine, I think I completed the theory section, right? All of you.
Yes, sir.
Is that on top of uh, physical or virtual, we install the VMware, right? VMware means a software for virtualizing our host machine. Okay, here it will be a physical machine or a virtual machine. So using a hypervisor tool or hypervisor software, we will virtualize our host machine, and top of the VMware or any uh, virtualized software, we will get, we can install different machine on top of this application, okay, virtualization application. So on top of the application, we will installing different OS like Linux, Windows, Red Hat, any flavor of OS we can install on top of this application, right? And all the software, all the operating systems.
Hello.
Yes.
Hi, Sunil. I'm good. I'm good. How are you, sir?
Yeah. Okay. So, and the top of each, these are operating system. Okay. So consider this is our computer 1, computer 2, and computer 3, like that. These are purely virtual machines. Okay. And top of the virtual machine, we will deploy the application. App 1, like app 2, app 3, like that. Okay. These are apps. This is a kind of traditional application deployment. So now, in modern technologies, we use mostly these types of uh, service like Docker, Kubernetes, Podman, Containerd. So many containerized application tools are available today. All are open source. So we use these types of services for deploying our application. Okay. So this is for this scenario, we know that so many problems, right? Like resource utilization for running a application, simple application or any application. We are running Ender OS. So many things are here, right? So it will utilize our memory, CPU, all the things, right? From the host machine. Am I right?
Yes.
Okay. So for this is a traditional way, okay? Traditional, not a traditional way. For example, nowadays we will install like this, okay, as per the requirement actually. So this is the thing, and when coming to Docker, we need a base machine, right?
Your voice just broke up right now, sir.
Give me a second.
It's working now.
Okay. So for installing Docker, we need a physical machine or a virtual machine, okay? So virtual machine or physical machine. And in our case, we will configure one virtual machine AWS, okay? That's fine. And we can install any OS, okay? So before installing Docker, the prerequisite is at least we have a physical machine or a virtual machine with a operating system, okay? That's the requirement. So here we will go with the virtual machine, that virtual machine running in AWS. Then any OS we can install for the base machine like Amazon Linux or anything. Okay, that's fine. And the top of the virtual machine, we will install Docker. You can directly install Docker on top of the machine. It's a software actually. So we can install directly from the remote repository, okay? After that, yeah, this is the basic stage, okay? Then we will install application on
Voice
top
is
of,
breaking.
sorry. Okay. So on top of the Docker,
Voice is breaking. Yeah.
again it's breaking, right? Hello?
I think now it is okay, but before it breaks.
It breaks a lot during the session. It is
If
coming and going, coming and going.
if it breaks, we can just tell him and he can repeat what he said because we miss what he says when it breaks. But it's like a bandwidth thing. Sometimes it's fine, sometimes it's not fine, right?
That's depend on, some I mean, I'm tethering from my mobile phone, so that's the reason I think, due to range issue or anything. But I have a stable 5G connection. That's good. I think I'm facing some network issue, but I'm audible, right?
Yes, you're audible. We heard what you said, but it compresses a little bit here and there.
Yes. Yeah, I think it's now it's audible, right? You can continue. Amor?
Yeah, I can hear you.
Okay, fine. Okay. And top of the Docker engine, we will deploy application. Okay. So we can deploy uh, any application. Give me a second, okay? Now I place my mobile phone some better place, okay? So it will get so many, much range. Okay, now it's stable, right? My voice.
Yeah.
Yeah, it's better.
Yes.
Better now. Yeah.
Yeah, much better.
Okay, fine. So
So, one question, Taufik. After the previous call, which was about the public and private IPs, is this the next call, or did I miss a class in between?
this is the next one. There's no
Okay.
section in between.
Oh, thank you.
Okay. And okay. Hmm. Leave this thing. Okay. So on yeah, first we will configure a virtual machine, then installing Docker engine, then we will deploy application. So each application is isolated. Okay. For example, I will install two application. So these two application will be isolated in Docker. There is no communication between these two. Okay, like this is, for example, this is a Python based application. Consider Python. Okay, Python application. This is Java. Like this is .NET or any application. As per the requirement, we can configure and launch different application. So each application will run inside a container. This is called a Docker container. Container. So this is container 1, this is 2, 3, and like that it will go as per the requirement. Then by default, there is no communication between these two, but uh, as per the requirement, we can create a network and connectivity between these containers. Okay, but default, it's isolated. Each containers are isolated. Then, yeah, that's the thing. So consider this is a virtual machine. Okay, so yeah. So this consider these machines have different layers. Okay, so the first layer with the operating system. So I installed a operating system. Okay, this is a physical machine. This will give you some idea about how a containers and how it works, all the things. So this is a physical machine, and this is our OS, base OS. Okay, for the physical machine. This will be like Windows, Linux, any OS we can install. And yeah, for the physical, we have some components like, for example, a physical machine in the sense of it will contain different devices like memory, CPU, then storage, then what's the next one? Anyone? Any idea?
Versions of software.
No, this is the first layer. I mean, softwares are from here, second layer.
Hard disk space for any partition
And
disks.
that is inside the storage, right? Okay, you mean RAM, right?
RAM, yeah.
The RAM is memory actually. This is RAM.
Memory.
Okay, RAM, CPU, storage is in the sense of hard disk. So it's covered. And also, important thing we are missing, right? Anyone? No idea, right? Network.
Docker network, okay.
Okay. So these are the uh, mandated thing for running a machine. Okay. I mean, this is for the operating system. Sorry, operating system second layer. Okay, that's fine. For the physical machine, we need a network connectivity for internet connection, memory for, I mean, for executing, process all the things. Then the CPU, that's the processor actually, and we need a storage for installing operating system, other applications like that. So then these are the main things. Okay, with this, we can go with the second layer, like installing software, right? For the physical machine. Consider this is a laptop or a personal machine or anything like that. Then we will install OS, okay? For executing and running OS, the OS needs these things like RAM, CPU, storage, all the things, okay? So we install the operating system, okay? Consider this is a Linux machine. So again, we will, this is in the Docker stage, Docker scenario, okay? Then we will install Docker. Consider Docker is a next layer of. So Docker installed. Docker installed. Okay. We called Docker engine, okay, the installation application. So Docker engine will manage the Docker container and all the things. So Docker is here, okay. So then we will deploy application, okay. Deploy application. So the application will create a container. So consider again we will consider this is a small, very minimal, small machine, like a a small minimal operating system. Okay, operating system with the same things like network, RAM, and CPU. Storage as well. Okay, we can enter the storage. Consider this is a very small machine. Give me a second. I will back. Okay, 2 minutes.
Are you still there, sir?
No, he said he'd come back.
Oh, okay.
Hi, hi. All are here, right?
Yes, hi.
So yeah, this is a minimal version. I mean, consider inside a virtual machine, we will create a small kind of machine to run a specific application. In a single word, it's called, we can use say like say container. So what is a container? Container have for running a container, the prerequisites are it's need a processing power, right? And RAM, then network, all the things to run a, needs to run a container. And the applications, dependencies, binaries, all the things to ensure, to need to ensure to running an application. For example, this is a Java-based application consider. So what are the prerequisites to run a Java application, right? So the Java application dependencies, we need to install the dependencies, then the libraries, the framework, and all the things we need to install. Then we will run the application, Java application. For the same scenario, it's a Python. Then we need to install the Python dependencies, Python library, framework, all the things related to the specific application. We need to install the dependency, all the things. Then we can running the application. So this is called a container. Anyone have any doubt?
No doubt so far.
What about others?
No.
Pilpa?
No,
As
nothing.
per all good.
So to running a application and building a container, we need a file. Okay, that file is it's a file for Docker actually. So the file name is Docker file. So for example, I have a application code. Okay, for example, say web application code. So how I deploy the application inside a container? There are several steps. Okay, we need to follow. The steps are, first steps we know, right? We have a machine, then we install Docker engine. Then from the Docker engine to the container, there is a step-by-step process. So that we need to follow. Okay. So the first stage is to create a Docker file. Okay, consider this is the first stage. So first we need to create a Docker file. Okay. Then we will build the Docker file. Okay, build in the sense of what are the metadata or what are the instructions inside the Docker file. There are some instructions. Okay, some blueprints. How the for example, how we deploy web application in a virtual machine. Simply we will configure the virtual machine, then install the Apache, right? Apache web server. Then what we'll do? We'll copy the application code to the specific directory, right? Apache directory, right? So these are the steps we follow to deploy application. Okay. So coming to Docker, we will, we will provide each steps. Okay. For example, in this case, we need to install Apache, right? Right. So, some codes for installing Apache, like apt install Apache or HTTP. So, same way, consider there is another same way we need to provide each step. Okay, inside our Docker file. So the Docker file mainly include these types of commands. So, for example, installing Apache, installing Nginx, and copy some code from one directory to another directory. So these are the blueprints. Okay, inside the Docker file. So when we build the Docker file automatically execute each commands what we are provide inside the Docker file. So we didn't ensure anything. All things, done by the Docker. Okay. Any doubt? Confusion, right?
Yeah, it's not clear that much. It's inside the Docker app.
No. This is not inside app. I will explain with the. Consider this is a Docker file is a Docker file contains some commands. Okay, different commands. Okay, consider different commands. Then we have just the commands. Okay, consider we have a file. This is a file, and that file contains different commands. Okay, so we need to execute these commands, right? How we will execute the commands? Using one Docker command. This is not a Docker command. Okay, uh, inside the Docker file, we use different commands, Docker commands and other commands, so many commands.
Is there any format for Docker file, or it's just telling about any file which contain
No. There is some format and some Docker commands we need to include the Docker file.
Okay.
Not the Docker commands, Docker keywords. Some keywords are there. Okay, keywords in the sense of like run. Run is a keyword. Okay, for running something. Okay, then copy, another keyword. We will cover these keywords when we will go. Start the Docker file. So we include some keywords inside the Docker file, and we need to provide the our requirement using the Docker keywords. Okay, so we have a Docker file. Okay, consider we have a Docker file. Then what will we do? We need to build the Docker file. So how we will execute these commands inside the Docker file using Docker build command. Docker build command is a predefined command inside Docker. Okay, so we will using the Docker build command to execute these commands. After the execution, we will get a Docker image. Here build happen. Okay, consider here build happen. Build. After build, we will get a image. Okay. So what is a image? Image is considered the image have the exact metadata metadata to run a application. So what are the things we are provided in the command, the Docker file? So it will execute and wrap up inside a Docker image. So that image is, it's a ready metadata to run our specified application. Okay. So now we will get the image. So the next thing is build here. The first stage is build, and the next one is run. This is another command, Docker command like Docker run. For which purpose we are using Docker run? To running the application. Running the image. Okay. So what will happen here? The Docker knows that there is a image for running the application. So using the Docker run command, this image will run. So
It will be deployed somewhere, right? Then it will run, right?
no. Deploy in the sense of
Like once the file is built, where it will run? Once it
in the
deployed,
same
then again.
directory. In the same directory.
Okay.
In the same directory, we will see the Docker image after we build. Okay,
Okay.
like yeah, we will get more idea when we will go with the lab. So
Okay.
yes, so yeah, using the image, we can run the application. So now the application is running. So this is called container. Got it.
Yes, sir.
So these steps we need to follow to, running a container-based application. So keep in mind, we need a Docker file. Then we need to build the Docker file. Then we will get the image. Then using the image, we can run the Docker image for creating the container and deploying the application. Clear?
Yes, sir.
So can I summarize? So the image is like the type of computer that you would want with all the right versions of everything installed in that sequence, right? And then each container is an instance of that image. So you can make many containers of one image, as many as you needed.
Yes.
It's like a virtual machine.
Yeah, but it's like a pre-made virtual machine that's its configuration is defined,
Right.
right?
Define where? Inside
In
the
your Docker file.
Docker file.
Docker file.
For example, yeah.
I think the word image comes from, like when they have when they scan the whole hard disk, this is the image you have installed on it. I think that word comes from there, right? Like this is the image of a machine.
Yes. We can say like it's a blueprint, right? That blueprint is
Blueprint.
ready to deploy. So consider we need to run a Python based application. Okay, in the same scenario, Python based application. So the Python based application codes are in our local directory. Consider, okay. So based on that, based on that, we need to create a Docker file. So we will create a Docker file for the Python application, and we need to provide the dependencies, libraries, all the things we need to uh, include in the Docker file. Okay, and even the code. Okay, Docker, the Python application code, all things we need to include in our Docker file. Then we need to follow the same steps, like we need to build, then we need to run, then we will get the Python application. Similar way, any application like Java or any application, we need to follow the same things. We need to create different Docker file for each application. Any doubt?
Yeah, Tawfiq, while creating the Docker file, for example, when we are talking about Python, if some libraries are missing or something is missing while creating the Docker file in the process of creation of image, uh, will we be able to create the image successfully, or will there be any errors? How do we identify if there are any issues in there?
Uh, First, we need to validate. Okay, for example, there is a developer there, so we need to check with the developer what are the dependencies, libraries, framework, all the things we need to ensure, and the version also. For example, different versions are there, right?
Mhm.
So we need to include all the things in our Docker file.
Now,
Okay.
how do we ensure that the image whatever the image that we are building is the right image? Because uh, I mean, if something is missed out, how can we identify?
If something is missed out, the applications, we can see the applications have some failure or anything like that. It's
Some
going to.
testing, maybe. You could test, maybe. Run some tests on the image to see if it's working the way you thought it
Yes.
was.
Mm,
For example, when we are running the image, okay, when we're running the image will, after build the image, we will get, build the Docker file, we will get the image, okay. So we didn't know that the libraries or anything is missing, but we will get the image, okay. Then we will run
okay.
the image. After running the image, this won't work. The container state is not like running or anything. Then we can check the container. So there is some Docker
Okay.
commands for executing the container status. Why the container is not running? All the things we can see in the
So the
Docker log.
responsibility lies on the developer, right? Whoever gives us the Python code. and other libraries that are required, the responsibility lies with him.
Yes, with him.
Okay. Not on us.
Actually, we are different. Some scenarios, the developer will write up the Docker file. Another scenario, we need to make the Docker file.
Okay.
Okay.
Likewise, if for running a React.js application in the Docker file, uh, React libraries, the dependencies, and the app, everything will be there. It is like that.
Yes.
If you installed it right? So it's like you prepare a
Like
machine for work. So same way, if you had, uh, if you miss
Express.js
something,
code.
yeah, if you forgot to install something on a physical machine, then it won't do what it was supposed to. But you carefully installed everything in the right configuration, then it should work.
But everything will be installed in the Docker file, not separately in the
So the
machine, right?
Docker file like specifies what you want installed.
Mm-hmm.
Everything we need to install in the Docker file.
Right.
Not in
Okay.
the Docker file, actually, we need to provide the details in the Docker file. The details means we need to, I mean, these are my libraries. Please install like that. These are my dependencies. There is a predefined command system inside Docker file. So the Docker file ensure all the things are in. So it will build.
Okay.
Clear?
Yes.
So simply we can deploy a sample application. Okay. So you will get uh, the idea. A web application. Okay. So first what we need? We need a virtual machine, right? So we can quickly deploy one virtual machine. I will go with the Llama Linux. T2 is fine. I'm choosing existing key pair. I'm changing my network subnet because it's pointing to private. I'm changing to public. I need a public IP, so I'm going to enable. Mission is successfully launched. Copy the IP, then using power. 3. The machine is up. I am switching from this EC2 user to sudo. I mean, now I am in root user. Okay, see. So sudo su is the command to switching from the local user to root to user. The font is clear, right? Much bigger, right?
Yes, sir.
Okay. So first I am going to update my package manager. That's fine. So now I am going to install Docker. Here, first stage is done, right? This is done. We install, we configure a VM with Amazon Linux, right? Amazon Linux OS. Now this stage is done. Now we are going to install Docker on top of this VM. Okay. So there is a command to install Docker in each operating system. Where it is. Okay. 6 minutes. Okay. So installing Docker in this is Linux. Okay. So we need to use the yum package manager. Yum install. Yum. Yes, again, my keyboard. I'm audible, right?
Yes, sir.
Any breaking?
It's clear.
So this is the command to install Docker. Okay. Now the installation going on. Yeah, it's done. So we can check the Docker is started or the status. We can check the status of Docker using systemctl command. Systemctl.
Status.
See the Docker status is inactive.
Like,
So we need to start the Docker. See now it's active. Okay. So this stage is done. We install the Docker. And the status is active. Okay. Now from here to the application, we need to follow up the stages. What are the stages or what are the prerequisite, the Docker file, all the things we need to create from here. So the first thing is we need a Docker file, right? So create a Docker file
yes.
using any text editor. nano. Keep in mind Docker file D is capital, okay? Otherwise, I mean, when building image, that doesn't work. Docker.
Your voice started to break
And
up, sir.
uh, is there any uh, is there any default path like for web app deployment? There is a default path, right, under HTML.
Hmm.
Uh,
I told
what's
you,
the default path for Docker?
yeah, I told you Docker is a minimal. Consider it's a small, very small kind of machine. That's so inside the machine,
Me,
same path, right? Like var, ww, same things. But all the application belongs to inside the Docker. That's all. I mean the Docker container.
Can we see the path here, like where we are deploying Docker, where we are creating Docker file?
Yeah, before the deployment. Okay, I mean before Docker, where we install the application. First we install the Apache, right? Apache. This is a virtual machine. Okay, VM. I mean the application deployment inside the VM. So what we'll do? We configure a virtual machine.
HTML,
We install a web server like Apache, right?
right?
Remember. Then where we keep the application goes,
Yes, yes.
ECT, I mean var www
Var www
HTML, right?
HTML,
Yeah,
right,
this is in the virtual machine, right?
right.
So when we are coming to Docker container, okay, I told you that this is a minimal version of this kind of virtual machine. Okay. So the same things happen here. Like this machine, this
Okay.
container have some minimal operating system. Inside the container, we install Apache. Okay. Inside the container, there is a directory path like var. And that directory, we will copy the application code. From where? From our physical machine. I mean the virtual machine to the path of the container machine. So using some keyword, we can copy uh, files from the host machine to container machine. Got it?
Okay.
So I'm going to create a Docker file. See, now the Docker file is done. We can go with some image. Yeah.
My question was without going to that directory HTML, it will by default create the Docker file inside HTML.
Sorry, once again.
Like while we are creating index.html file for running web app,
Hmm.
we need to go till that path like till html. Under that, like we need to navigate to html. Under that we do nano means nano index.html. So
Yes,
similar we are not doing here, right? Docker for
yes.
creating
We do same things here, but different way. That's all.
okay,
In this case, uh, we go with the corresponding directory like var www.html. I mean, we go to the HTML directory. Then from
right,
HTML directory, we will create one file index.html, right?
right.
So coming to Docker, okay. Uh, Coming to Docker, actually we are here, right? I mean, so this is our working directory now. The working directory means the virtual machine directory, right? The root at the, I mean, EC2 machine, okay? So now we are creating a container, okay? Container is in another instance of the machine, okay? So from here, we will create a index.html. Index.html file we keep here in the local directory. I mean the local machine directory or the host machine directory. Then we will create a command for copying this index.html file to container. image, sorry, container. There is a command we provide in the Docker file. So when executing the Docker file or building the Docker file, the Docker files know there is a index.html file in the host machine. So that will pointing to container machine var.ec2 sorry var www directly that we will
Your
create.
voice is cutting up, sir, again.
Now it's stable.
Hello.
Yeah.
Yes, it's stable now.
Okay. Miss out anything?
Uh, yeah, we are going through that nano. You are creating the Docker file, right? Nano by using nano command.
Yes. Nano Docker file. That's
So it is under directory root, is it? That I wanted to know.
yeah. We can place the Docker file root or anyway, but I'm just going to the root because sometimes we miss the sudo. That's why
Mm-hmm.
any directory we can keep the Docker file.
Try pwd where you are, so you'll know where you're
Yeah,
living.
that yeah.
Okay. There are some keywords. There are some keywords there. Okay. I will go with the keywords coming section. Now we can deploy a simple application. See, this is a Docker file for deploying a HTML application. Okay. So here you can see these are the keywords, the capital ones from leave this one. This is actually depreciated one. So then the next command is sorry, next keyword is run. Okay. And next one is copy and expose and report. These are the Docker keywords inside a Docker file. There are so many other Docker, I mean, keywords there. For this application, this requirement, we are using these keywords. Okay. So, mm, yeah, I will quickly explain these things. Okay, because time is eight, like lately. So the from command, this is for where the image. I mean, for example, we need a image for running a container. Okay, image in the sense of a minimal OS. Okay, so coming to container. Okay, this is container. We are creating a container. So the container need a small size operating system, a minimal OS. We called as a minimal OS. For the virtual machine, we install a Amazon Linux, right? Instead of, I mean, same things. We need to install a small size OS. For Amazon Linux OS size is like 1 GB to 3 GB. Okay, consider this. This is a file size for the full OS. Coming to the minimal OS, the file size like 100 MB to 200 MB or 300 MB like that. We can choose as per our need. We can choose with the go with some small size images are available like below 100 MB. Okay. So first we need to choose the which OS. So here you can see Rocky Linux. This is a Linux operating system I am choosing for this container actually. Okay. So then leave the main. Then we need to provide the installation of Apache web server using the keyword run. So again, I am going. Next keyword is run. Run is nothing when executing the Docker file, okay, or when building the Docker file. When building the Docker file, what are the keywords we provide in the Docker file will execute. So in this case, okay, first stage is it will go to the from command, they will searching the Rocky Linux latest from the internet. Okay. I mean the Docker file looking to the internet, and there is a corresponding files we can download available in internet. So it will download the latest image. Then the next one is run. Using the run command, what are things we provided after run, like yum update and yum install HTTPD and cleanup. So here this is for installing the Apache HTTPD. First it will update, checking the update, yum update, then HTTPD, install the HTTPD. See, all the things done by Docker file. Okay, we didn't manually install each things. Then after the Apache HTTPD, yum cleanup, clean all things. Okay, so this is for install Apache 2. Then the next keyword is copy. This is for copying something from one directory to another directory. Okay, but don't one directory to one directory. This is purely copying from the host machine to container machine. The command like this: copy host machine file name to container machine path. This is a container machine path, and this is a host machine file name. So we need to keep a index.html in our working directory. Okay. Then expose. This is for exposing ports. Okay. Inside container there are ports, right? I told you it's a minimal machine like the virtual machine. So coming to container, there are ports, virtual ports there. Okay. Same ports, 0 to 65,536 ports are there, logical ports in container. So we need to open the ports for accessing the application. So in our case, I am exposing port number 80 for accessing our web application. And here we can change as per our need. Okay. This is for the web application. That's why it's pointing to 80. Then this is a way we open the port in container. Okay. Using the expose command. Sorry, expose keyword. Then the entry point. This is another keyword for example, after running the container, the container, uh, running the container will start the HTTPD, the Apache in foreground. That's the requirement. Okay. For example, whenever the container start, the Apache will run automatically. That's why we are pointing the Apache to entry point. For example, we need to run a Java application. So when the container start, we need to automatically run the Java application. So we can use the entry point and specify the Java application here. Okay. So this is fine. I'm just to copy, save and exit. Any doubt, anyone?
It's fine, sir.
If you have any doubt, just point it out. Okay. We will discuss later. Now, where is PD deploying the application? LSC Docker file is there. So I am going to build the Docker file. So there is a command to build. I didn't create a index.html file in the Docker directory. Sorry, it's a host directory. So we can see the error message there. Okay.
But it was there in the Docker file command, right? Inside the Docker file, that
Command there,
command
but
was.
yeah, but when we build the Docker file looking for the index.html in local host or this directory. See here, the only Docker file is there, right? So
Right.
that won't work actually.
Means it should be there in the local directory, and then only that command will work. That command was to copy from local
Yes,
directory to the
yes, yes,
Docker. Is it like that?
yes. The copy command using for first we need to provide the file name in the local machine. Local machine means this Amazon Linux. Okay, from
Mm-hmm.
and we need to provide the container path. The container path
Uh,
is same like one www.html.
but in the command copy index.html only, it the full path was not written. Is it not needed? Where the index.html file is located in the local directory?
No, because we will create an index.html in the same directory. This is our working directory in local machine. The working directory means
Yeah, current directory.
yes, current directory, home, ECT user.
Okay, you are going to create here.
Create here, yes.
Okay.
Here
So
we
will
need
it
to
work?
ensure where the Docker file belongs, which directory Docker file belongs. The same directory we need to keep the file. Otherwise, we
Okay.
need to provide the path as well. For
Okay.
example, index.json file in other path in our local machine. Then we need to provide the path with the file name.
Okay.
Okay. So I'm going to build the image. Okay. So build, how we build the Docker file using Docker command. There are some Docker commands we need to learn, like Docker run, Docker build, Docker ps, Docker port. There are some commands there. Okay. So you will learn. I mean, Docker build. We need to provide a name for our image. So I'm providing an app. Then the directory, the current directory, choosing the directory. Okay, just hit enter. See, this is the command for building Docker image. So Docker build dash t, then app. App is the image name. Any name you can give. I choose app, then space, then we need to point the directory. So I am using the same directory, that's I am space dot. So it will uh, execute like the Docker image. So there is a error. See, copy index.html error because the index.html file is not in our working directory. That's why.
Available in that
Yes.
current directory.
Yes. So we will create a.
You have to make it there.
Give me a second. Yeah, I'm going to create one index.file. Okay, in HTML.
Or you can edit in the Docker file the path of the index.
No, nothing.
Either way, right?
In Docker file, that's fine. We already mentioned that there is a file in. We will rebuild the file actually.
Your voice is breaking up. We cannot hear.
Now it's stable. Now it's clear, right?
Yes, sir.
Yes.
Okay. I copied a sample application to the index.html file in my local machine. So exit, save and exit. Okay. Now I again build the application. Okay.
One question. You said you wrote Docker build minus t app and dots for current directory, right? But if
Hmm.
you put in some other path, would it build the image in some other path on the local machine?
Hmm. I think we need to provide the same working directory. So because all the Docker, I mean, what are the images we will get after running the Docker file? Okay, so all things will be in the same directory. We can see in the same directory, like EC2 user. Okay, like this directory. Got it?
It is under home at EC2.
Yeah, we are in home EC2 as root user, root power, root privilege. Yeah. So now we build the Docker file, right? So after build, or we can search the images in our Docker. We can using a command like Docker images. This is a Docker command to view the Docker images. See here, the app is here. This is the image we created. So the next step is we need to run the image, right? So how we will run? Again, there is another Docker command to run the images like Docker run, Docker run.
App.
No. We need to provide some commands like we need to detach mode. Okay, like after executing.
Image name you have to get Docker run image name.
Yes, Docker run detachable mode. Then we need to specify the port, which ports that listening. So -p, and we need to specify the port number 80, colon 80. 8080 means first 80 is pointing to container port, then the second port is local machine port. Okay, I will explain that thing. Then the name. This is the name tag. I mean, name of the application that we are going to create, or the container name. Okay, and the image name. Both the name we need to mention here. So I am going to first we need to provide the application name. Test or web. Okay. Then app, the image name, the same image name. Okay. And
Web, what is this? Like, what type of app it is?
no. Web
Image.
means the name of the image. Our image name is, sorry, app is our name of the image. See,
Right.
our image name is app, and the web is the name of the container. We can choose any name. I'm just choosing the web. That's all.
Okay.
Now we can see there is a container is created. So how we can see how many containers, or how we can see the containers, the Docker containers? There is another command to viewing the running Docker commands. Okay, so the command is Docker ps. See, our container is running. This is a container ID, and the image is app. We are using the app image, and the command is been and created is 43 seconds ago, and status is up, and the ports we binding with the port number 80 TCP, and the name of the container is web. That we provide web. Okay, so everything is everything seems good. Just to go to container and accessing our application. Okay, so before that, just copy the public IP and paste it. Intent are nothing, pointing to 80. Nothing, because we didn't enable the port number. So just to go to security. Enable the port number 80, okay? Because see, when I am running the Docker image, I am choosing the port, okay? This is dash P for choosing the port, okay? So these are my uh, port binding, okay? So this is my physical machine, right? Consider this is a machine, physical machine, and inside the machine we install the Docker, okay? And inside the Docker we deploy one Docker container, right? So Docker container have network and all the things, right? So I enable the port number 80 for accessing the application for the container, okay? This is a container, Docker container. So inside the container, the application there, okay? So through the port number 80, all our can access our application, okay? This is purely for Docker. So first hitting, for example, a remote user first hitting our virtual machine, right? So we need to enable the virtual machine port as well. So here we go to enable the port number 80. That's, I'm going here, like, see, edit enable, add port, port number 80. Yeah, HTTP is fine. Save rule. Who can access? Anyone can access. So this is done. So the users can accessing the port number 80 of our virtual machine. Okay. Then it's pointing to the container machine port number 80 and viewing the application. This way we are accessing the application. See, I'm going to reload. Yeah, that's fine. See, this application purely run inside our container.
So what's the advantage? We installed in the local machine also, and we copied the file, that indexed file, in the Docker also. So what's the advantage? We did twice the same job.
Uh, that's that's why I explained the previous traditional way. Okay. For example, y- you know, give me a second. So you told like previously we deploy application in a virtual machine, right? A virtual machine. If we take a Amazon Linux machine, then install Apache. Okay, Apache and install the I mean deploy the application. Okay. Now we are in container. So what's the difference, right? That's the question, right?
Right.
Okay. The cost that yeah. So in this case, we deploy a application, web application, and we took a full VM, right? You got scenario. First scenario is for running an application, we utilize a entire OS here. Entire OS in the sense of like Amazon Linux or Ubuntu, any OS for running this application. In this case, we similar way we run the entire OS and we utilize the entire machine, but for the specific application, we only using a single container with the minimal storage, CPU, network, all the things. And we can deploy so many applications like this, creating another container, another container. Then the next scenario, uh, consider this is a production environment, production application. Okay, we install this is we configure a virtual machine, then install Apache, then deploy the web application. This is a production application. Okay, production based application. Okay, so sometimes this application move from this virtual machine to another virtual machine. How we will migrate from this entire application, because there is because this is a production level application. If we moving from one to another machine, there is some impact there, like business impact or anything. So it's a crucial thing, like from local, I mean, like copying from copying enter application and depends all the things from one machine to another machine. Okay, that's a messy thing, right? So coming to the container scenario, we can simply copy the image. Only we can copy the image to another machine. You got it? We have the
Yes.
exact blueprint of the application. We successfully run the application, and we can say the image is good to move. That's why the Docker image can ship, run, and build, right? Ship
Uh,
in the
uh,
ship in the sense of shipping from one machine to another machine. For example, in our case, we have this application image, right? This is the image of our application. So I can upload this image to my Docker Hub. So anyone can download the image. They can simply download the image like Docker. Then we need to just say the path of the Docker Hub application. Then within a single seconds, we can install the image to any machine across the globe, and they can simply run the application using Docker run command. You got it. For example, if I upload the application image in my Docker Hub repository and send it to you, you can just install the image, and using this command, you can deploy the application in your machine or your container, Docker container.
yeah, but in the image, whatever command is there, if there is a mismatch of command in the system, new machine, so it will throw error, right? Again, we need to build it.
Sorry.
The image which has been created for one machine,
Hmm.
if it is we are going to deploy the same image into the another machine,
Hmm.
and like some dependencies are there, like we copied something from that local
Yes,
machine, the
yes.
path are there.
Yes.
So if it is changed in the new machine, so it is going to throw error, right? We need to build again.
That we will copy sometimes. If we can use the same image, it will see some image, some errors, I think. We need to copy the image, that index file as well, to the remote user.
Hmm. Okay. With the app, we need to copy other things also.
Hmm.
You mean? Okay.
Using image, you can access it. I mean, this application, you can run the application using the image. You didn't copy anything because we already copy and wrap up in our image, right? We build the image. So inside the image,
Mm-hmm.
our application there, like index.html.
Mm-hmm.
For example, you can directly run the image to view the application. You didn't bother about the Docker file or the index.html in your local machine. Got
Okay.
it? Yeah. If I send the Docker file, then you can keep the index.html in your where the your working directory. I mean, where the Docker files belongs. So the same directory you keep the index.html file. Then you can.
Okay.
Otherwise, you can run the app file directly. You can see the same content. Got it?
Yes.
Yeah. So this is a simple way of deploying a web application inside a container. So all are good. We can, wrap up, right?
Yes, sir. So just one
Yes.
request, after completing each session, it will be helpful if you upload the recording as
Yeah.
soon as, so that we, because it's taking a time, like 1 week it takes, so many pile up, then it's difficult to do.
Mm. Yeah, that
So it will be
problem.
helpful if we'll do it in the same day.
Sure, sure. The some technical issue in between because not it's a technical, say
Mm-hmm.
miscommunication from the person who upload the things. That's a time delay in between. So I will
Sorry.
Oh,
post. There is three section. I think instead of I mean include this. There is three section pending, right?
right, right.
Yeah, I will upload the all threes and share with you.
Yeah, that will be helpful because some of them we because of some reason we miss the class, and if it is not uploaded, then to cope up it's difficult, like two
Hmm.
three
Yeah,
session.
I know, I know. Yes. Okay.
Yeah, that's all from our side.
Uh, Okay. Yeah, I will keep it posting. Okay, no problem.
Yeah, thank you, sir.
Yep.
Good day.
Yeah.
Thank
Good
you.
night.
Have a good night. Good day. Good
Bye
day.
bye.
Yeah.
Bye. Yeah.
Bye.
Bye. Bye.
Yeah, thank you.
Yeah.